Hello everyone. Here is the question that we are having. Let's read it out. Find the value of the angle of emergence from the prism. Refractive index of the glass is √3. Refractive index is given to us and we have to find out the angle of emergence from the prism. Here you need to understand that one thing is very clear to us, that TIR is not happening. This ray is going and definitely it will pass out from this side of the prism. It will not going to show TIR. So we don't have to worry about this. So let me first of all take the name of this prism, so it will be easy for us to pronounce which side we are taking. So let's call it ABC. As you can see, AC is the interface right now that we are discussing. On the face AC, the ray is coming and striking on the face AC. So the angle of incidence on this face I is equals to must be equals to 0. You must be thinking why I is equals to 0, because it is 90 degrees, so it must be 90 degree. Then for all those students who are having this type of confusion, I would like to let you know that angle of incidence is basically the angle between the incident ray and the normal. Now, it might happen that you could not be able to see the normal. Let me draw it for you. Here, actually, this is the normal, right? As you can see, both the normal and the incident ray are overlapping. So we can say the angle of incidence must be equals to 0 at the interface AC, right? And let's talk about the angle of refraction. And we know when angle of incidence is 0 degree, the angle of refraction must be equal to 0 degree, because I have already taught you that whenever a ray falls normally on any face of the prism, then what happens? It will not suffer any refraction at all. So if I is equals to 0 at the interface AC, R must be equals to 0. This should be clear to you, right? So let me also write this thing, that I is equals to 0 here. So R is equals to 0 also. So let me complete this ray first of all, like this. So this is the ray which is coming up to here. Let me draw it properly so that it could be clear to you. So like this. I hope it is quite clear. Now, what will happen after this? We will talk about it, how it will emerge out from the prism. But first of all, let's apply some basic geometry from your geometry class. Now, can you see it, right triangle ABC? Yes, you can see. Now, what is this angle? This is 60 degree. This is 90 degree. Can you apply angle sum property and let me know what is this angle? You will simply say, sir, this is quite easy. This is 90. This is 60. So it must be 30 degree. Correct? So this is 30 degree, as you can see. Now, can you see this small triangle? Let me show you which triangle I'm talking about. This small triangle, this one, right? Can you see this small triangle? Yes, you can see. Now you need to understand what is this. This is 30 degree. This is 90 degree. Can you tell me what is the angle of this? The measure of this thing is equals to 60 degree. You can again apply the angle sum property. Okay. Now let's draw the normal first of all for the interface AB. So I'm going to draw the normal. I hope you can see. This is the normal. Now you need to understand that this is glass prism and this is denser, right? This is the air, so this is rarer. And you read when light travels from denser to rarer medium, it went toward the normal or away from the normal. I know that your answer will be it went away from the normal. So let me complete the ray like this, right? So let me properly draw it. Right. So this is the angle that you have to find out, because this is the angle of emergence, correct? Now, one thing is very clear, that this angle of emergence must be greater than this angle. So what is this angle? You know, this total is 90 degree. This is 60 degree. So this must be 30 degree. So what is the angle of incidence at interface AC? Sorry, AB. At interface AB, what is the angle of incidence? It is 30 degree. What is the angle of emergence? It must be what you have to find out, right? So let's do it first. Let me write it. At the interface, I'm writing at the interface AB. You can see at the interface AB, what we have to do, we have to find out angle of incidence in the tensor medium. You need to remember. So let's call it I dash, because I is already used, right? So let's call it I is equals to 30 degree. Now, what is E? This is what we have to find out. Here, I need to tell you what we are calculating: refractive index. What is the refractive index of the glass prism? They have already given it. So let me write it. Mu is equals to √3. And what is the refractive index of air? You all know that this is 1, right? Now, you need to understand when light travels from rarer medium to the denser medium, or I could say when light travels from air to the glass, then the refractive index written like this: refractive index of glass with respect to air, and this is actually √3. But right now the light is coming from the glass into the air, so the refractive index should be Ag, and you all know the formula is there. So this is Ga, and this is equals to 1 by √3. So now it is clear that refractive index of mu Ag is up to us. I dash is equals to given right now, and E is what you have to find out. Let's apply the Snell's law. Let me make some space for this. Just a minute. I'm going to apply Snell's law. You know that what is Snell's law? Simply mu, and since the light is coming outside air, so we will write down mu Ag is equals to sine I dash upon sine E. So mu Ag is 1 by √3. We have already calculated. What is sine I dash? It is sine 30. Sine 30 degree, and sine E is what we have to calculate. Let's do the cross multiplication. Sine E is equals to √3 sine 30, right? And what is the value of sine 30? It is √3 into 1 by 2, and this is coming out to be √3 by t, √3 by 2. So this is sine E. Sine E is equals to √3 by 2 is actually sine 60. So we can say the angle of emergence is coming out to be 60 degree. I hope each one of you got this question correctly. And so the correct option would be B option. I hope you got it. Thank you very much for your time.